Throttle body fuel injection systems are becoming very, very popular, like this Holley Sniper unit we put on the 64 Corvette. And the promise is that they're easier to start, they have better throttle response, they don't have problems like vapor locking, you can let the car sit for a month, turn the key, it starts right up. Plus they have self-tuning modes so that they can constantly improve the calibration as you drive, and their overall drivability is better. But there are times that we find installing one of these systems leads to frustration. Sometimes these things do weird things, like they'll run for a little bit and then just shut off. Or they will get to a certain temperature and then it'll run erratically and then shut off. Or it won't start at all, right? So today we're going to look at a few things that you need to check before you finish your install to make sure the rest of the car is ready for your high-tech upgrade. Now, one of the reasons why these systems are so cool is because they are very self-contained. So in the Holley Sniper, for example, the electronic control module that runs this whole thing is actually built into this unit. So it makes it very compact and it minimizes the amount of wiring you have to do. But what we have to remember is that we're putting this modern high-tech piece of electronic equipment into an engine bay that could be 30, 40, 50, 60, 70 years old, right? And the rest of the electronics under the hood might not be up to par. They might not be in perfect condition, they might not be working properly. So what we see is a phenomenon called EMI or RFI. It's electromagnetic interference or radio frequency interference. And basically what that means is that there are things under the hood that give off radio frequency waves and electromagnetic waves that can affect the ECM buried inside this unit. So the very basics are really important to follow. The first thing is we've got to make sure that the power and the ground wire for this unit go right to the battery and that they've got clean connections and that all the rest of the connectors are put together properly and that they're solid connections and all your grounds are clean and not corroded. The next thing to pay attention to is when running your wires and your cable harnesses, you want to make sure that your signal wires, meaning the ones that go to the handful of other sensors on the engine, are not bundled with power wires for other things. So you don't want to run your ignition coil wire power along with like the throttle position sensor because the interference can transfer from one wire to the other. If you do have to cross wires, don't bundle them this way, try to cross them at a 90-degree angle and that'll minimize that crosstalk. But the biggest thing is that there are other sources of this magnetic interference or radio frequency interference, namely the alternator, the ignition coil, and the distributor. The alternator is a device that creates electricity and it does it with brushes on an armature, and as it spins, there's an arcing function that happens inside there. Well, that radiates that arcing electromagnetic interference outward, and it can directly affect the way this thing performs. Same with the ignition coil, and definitely same with your spark plug wires. Spark plug wires are famous for wearing out and becoming brittle, getting micro-sized cracks in the coating, and then radiating out electromagnetic interference that can be arced over to a part of the block or the headers or something, and then again causing this unit to get confused with that interference. Same with the distributor. You want to make sure that the distributor has a good cap, a good rotor, the alignment is all set up properly inside there, and also same with your spark plugs. In the 1980s, we started to see resistor core spark plugs and wires that said radio suppression on the plug wire because electronics started to find their way under the hood. And those types of products are designed to minimize that radiation of these electromagnetic waves. So it's always a good idea to put a new set of spark plugs in the car, a good set of wires. These MSD superconductor wires have proven to be pretty good for keeping their signal inside the wire and not spreading it around, and then also a good distributor. A worn out distributor might wobble inside the housing, causing arcs underneath here, which can also throw this thing off. So minimizing the sources of the RF is kind of the first step. The next one is to try to minimize the sensitivity of this unit. And if you look closely at ours, you'll see that the air cleaner stud is white. Well, it's not a piece of steel. We've changed it to a synthetic material called Delrin. And it's a threaded rod, but it's no longer acting as an antenna, porting that electromagnetic interference right down into that ECM. And here's another thing to check for. This air cleaner, sometimes you'll see a situation where the fuel injection car will run just fine until you put the air cleaner on. And if you put the air cleaner on, all of a sudden it starts to sputter and it doesn't run properly. Well, this thing is acting as an antenna, and it's picking up RF from the distributor or from a wire that's close to it, connecting it right to that stud and running it down into the ECM. So that can throw all kinds of things off. So a lot of times when the car doesn't run right, we tend to look at sensors and say, well, I've got a bad throttle position sensor, or I got a bad coolant temp sensor or something. And we're finding more often than not, if you look at the data log, if the car actually runs and you follow the screen and all of a sudden one of the sensors reads a value that either spikes immediately or goes into a negative where it's not supposed to, that's generally a sign of electromagnetic interference. And some of these ECMs can reset so fast that the car won't even stop running if you're driving it. It'll just reset itself, keep going until that next occurrence. We've also seen instances where the alternator has created so much noise that it just creates all kinds of voltage spikes. So you can isolate that by taking the belt off the alternator and start the car and data log again and see if you've got a smoother curve. And if you do, you know that that's the source. If your alternator is a big problem, make sure you got good wiring, good connections. Might have to replace the alternator. So for ignition coils, we recommend getting them as far away from the ECM as possible, minimum of 6 inches, move them off to the side, make sure you got a good cap and rotor, make sure you got good wires. And the last resort is to try and shield this stuff. You can put metallic shields around these different components, but if you get all of the RFI under control, chances are you won't have to shield anything. So I hope these tips help you out. When we're talking with a customer about installing one of these systems, we're always recommending those new plugs and wires and everything right off the bat. One fun check you can do at home, pop the hood on your car and run it at night in the dark, and if you can actually see sparks coursing through your plug wires, well, it's time to change them. And they might be okay. You could take a piece of wood and, like a yardstick or something, and move them around, and they might create little arcing patterns. That's one way to know that those things are the culprit. If you'd like more help with this or like an install like this on your own car, you can reach us anytime at v8speedshop.com. We're happy to help.